Unit 3, Triangles, Lesson 3.1, Triangle Sum. You should be here in your preview notes, Lesson 3.1. Please make note of both the location as well as the date and time, and don't forget to get a parent, guardian, or teacher signature that you are watching these videos. Please turn off all distractions. Do not multitask while you are watching these videos. Let's do a review problem first. We're going to write an equation of a line in slope-intercept form, which has the following description. Slope-intercept form, which is y equals mx plus b, which has the following description. We want it to go through -1, -5, but perpendicular to the given line. This is our given line. And then we have our desired line, which has two qualities. It's perpendicular to this line and goes through this point. So first step, we need to figure out how to interpret perpendicular. We know slope times slope is -1. Write that down, please. So you plug in what we have. -1/3 times something is -1. You have 10 seconds to fill in that blank for the something. You should have written 3/1. So our desired line has a slope, or an m, of 3/1. Let's write our slope-intercept equation of a line over here. Y equals mx plus b. Now we only need two things. We need the slope and we need the y-intercept. Note, we already have the slope, so let's plug that in right here, 3/1. We're obviously missing the y-intercept. But let's backtrack and look what we actually have. We have a y right here in a point that's been given. So we're going to plug in y, circle, draw an arrow, plug it in. And we have an x. Can you circle x? Circle the x up here, draw an arrow, plug it in. Now we're going to solve. B equals -2. So our given line is red, and our desired line is going to be y equals 3/1x minus 2. That is our desired line. Let's see if this actually works when we put this on the graph. Our given line, y equals -1/3 x plus 2, so we start at plus 2. It's a negative line, so I'm going to go up 1 and to the left 3, or down 1 and to the right 3. That is y equals -1/3 x plus 2. Now this one, y equals 3/1x plus minus 2, looks like this. We can go up 3/1 or down 3/1. Graph our line. Y equals 3/1x minus 2. Let's see if we sufficed both of our requirements. Yes, it is obviously perpendicular, and -1, -5 Look, there's the point. It goes through it, -1, -5. Now let's address our new information for today. For today, we're going to talk about what kind of triangles are out there and a couple important, very simple qualities about triangles. First, we're going to start with triangles that are classified by their angles and then classified by their sides. First classified by their angles and then classified by their sides. Classified by their angles. Triangles that they are acute, obtuse, equiangular, and right. Acute angles would be a triangle whose angles are all less than 90 degrees. Less than 90 degrees. Obtuse would be a triangle where there's obviously one angle that's bigger than 90, bigger than a corner. Equiangular is where all three angles are equal. And right, of course, is when one angle is a right angle. Those are the four classifications for triangles by their angles. Then we have classification for triangles by their sides. There's only three. These three are scalene, isosceles, and equilateral. Scalene. No sides are equal, so we're going to have distinctive hatch marks. Notice the hatch marks do not match. None are equal. Isosceles has two equal sides. And the point hinged on the two equal sides is called a vertex. Equilateral, of course, is where all three sides are equal. By this understanding, all equiangular are automatically equilateral, and all equilateral are also equiangular. Using these 7 classifications, let's do the following problems. We're going to classify these triangles both first by its angles and then by its sides. Let's take a look at the angles. One of them is 90, so automatically we know that this is a right. Look at the sides. None of the sides match. So we would call this a right scalene triangle. A right scalene triangle. Number 2, it says draw below an isosceles right triangle. Isosceles, two sides are equal, right, one right angle. So two sides equal, that's isosceles. And the right angle must be squeezed between the two equal sides. I'll explain why in a little bit, but that is a necessity. That would be an isosceles right triangle. Last one says draw triangle ABC as an isosceles triangle with vertex B so that AB and BC are congruent. So we're going to draw ABC and it's isosceles. So let's start with that. Isosceles means two equal sides. B is the vertex, so B is hinged between the two equal sides. And we want AB to be congruent to BC. Now we have a diagram that reflects the description. Page 9, I'd like you to pause this video and do these 4 problems by your own. Welcome back. Let's see how you did. We want to classify these by sides and then angles. By sides and then angles. So sides, I'm in a box. Angles, I'm in a circle. Sides. Take a close look here. None of them are equal, so this is going to be scaling. Angles, all of them less than 90, so it is a scaling acute triangle. Here, sides, 2 of them are equal, so I would call this isosceles. Angles, 1 of them is right, so I would call it an isosceles right triangle. This one, by sides, none of the sides are equal, so I'm going to say scaling. Let's take a look at the angles. I have a right angle, so I would call that a scaling right triangle. Here, by sides, all 3 are equal, so I would call it equilateral. Here, by angles, I would call it equiangular. Those are the 7 different kinds of angles and their classifications you need to be able to work with. Now we're going to move on to 2 very basic properties about triangles. Imagine if you had a paper triangle. So let's say this triangle here is on a piece of paper, an actual paper triangular cutout. And you had the corners colored, angles 1, 2, and 3. If you were to cut this corner 1, cut this corner 2, and cut this corner 3, and then arrange them so that their vertices all line up together, they all hinge together, what you're going to notice if you were to rotate those 3 angles around, and those 3 wedges that you were to cut, those 3 corners would automatically add up to 180 degrees. This leads us to an extremely basic but very useful piece of information. In Euclidean geometry, and that's the kind of geometry we're studying, it's called geometry on a flat surface versus geometry on a spherical surface, which is a completely different course. But for geometry on a flat surface, triangles, the angles of a triangle, 1, 2, 3, always add up to 180 degrees. Knowing this, you have another simple concept, is that if you have a right triangle, since we add up to 90, that means these 2 angles here, the light blue and purple, they must add up to 90. There's a word for 2 angles adding up to 90. And that is complementary. So we know if we have a right triangle, the 2 acute angles are automatically complementary, which means, again, they add up to 90 degrees. Let's put this property to practice. Let's take a look at this diagram here. It says find anything and everything possible. If you have 3 colors, I recommend you get them out. So I'm going to start just by sweeping the angles in. I'm going to start first actually by tracing my triangle just to get in my mind, oh, I know that adds up to 180. Physically trace the triangle. Now let's sweep the 3 angles. We have a blue angle, for me, whatever color you're using, and another color and another color. Always write a thing equation before we work with algebra. That's really important you get in the habit of doing that. A thing equation is like this. I know in this case my blue angle plus my green angle plus that purple angle, because it's a triangle, has to add up to 180. So you use a thing equation before you do an algebraic equation. Now we have our thing equation. Let's do our algebraic equation. Circle that angle. Physically pick it up what it equals. Plug it in. Circle the second angle. Physically pick it up. Plug it in. Circle this angle. Now wait a minute, there's nothing there, but that's an easy fix because we see we have bow tie angles there, or vertical angles, so we can just carry it over. So now circle and pick it up. Now you have your algebra equation. We're going to collect like terms. We have 2x's plus 32 plus 42 plus 122. We're going to add that up here in the margin. 2 plus 2 plus 2 is 6. 3 plus 4 is 7. Plus 2 again is 9. And then 1. So I have 196. Equals 180. Now what we want to do is solve for x here, so we're going to minus 196 both sides. We end up with 2x equals negative 16. We divide 2 by both sides, and we end up with x equals negative 8. From here, we take the negative 8 and plug it in. Negative 8 plus 32 is going to equal 24 degrees. Negative 8 plus 42 is going to equal to 34 degrees. And then, of course, we have 122. Now, what's really nice is this is really easy to check. Let's check here. We're going to do 24 plus 34 plus the 122. 4 plus 4 is 8, plus 2 is 10, carry the 1. 2 plus 3 is 5, plus 1 more is 6, 7, 8, and there you go. You know it adds up to 180. Let's take a look at this number 2 down here. we're given the fact that measure angle 5 is 70, so I'm going to put a 70 here. And the measure angle 4 is 45. We want to find all possible angles. Now there's a really important notation that if you overlook it, you're going to mess up the entire problem. Please make note. Do you see these little arrow feathers? These arrow feathers mean that this line, I trace over it please. This line down here, extend it please, are parallel. Now that you see the parallel lines, you should immediately recognize some important properties, including armpits of the Z. Trace with me. Of course, that's 45 degrees. There's another armpit of the Z. I'd like you to trace it. You have 5 seconds to find the other armpit of the Z, also alternate interior angles. You should have done this. Armpits of the Z. 70 degrees. Now that we've transferred those, it's really easy. We have this one angle, and all we need to do is add up 45 and 70. That's 5. It's 11, 115. 180 minus 115. 5 from 10 is 5. 1 from 7 is 6. And angle 3 has to be 65 degrees. So when you have parallel lines, always hunt for alternate interior angles, armpits of the Z. They are extremely common. Be careful not to overlook them. With this information, I'd like you to take a shot at this page completely on your own. Pause the video, complete this, and then come back. Welcome back. Let's see how you did here. Step 1 is you always want to trace the triangle just to physically register in your brain where and what adds up to 180. Next, we're going to sweep the 3 angles inside that triangle. Now I'm going to make a thing equation. We know that the blue angle, in this case, plus the green angle, plus the purple angle, equals 180. Problem is we're missing both the blue and the green. But let's take a look and see what we can do here. Can you sweep the 150? And you should have gotten this blue angle being 30 degrees because it adds up to 180. And then these are vertical angles, so they're congruent. So this one's going to be x plus 11. Now we have all our angles. We can plug it in. Circle, physically pick it up, plug it in. Are you circling the angles and physically picking up? I hope so. This will help keep you from making very simple mistakes. Collect like terms. Of course, we have 2x. And here I have 30 plus 11 plus 61. That's 2. That's 102. I end up with 2x equals 78, therefore x is 39. We're not done. It says find everything possible. So if x is 39, that means this angle right here is 39 plus 11, which is going to be 50 degrees. And this angle right here is going to be 61 plus 39, which is 100 degrees. Now let's check. We have 100 and 50 and 30. Yes, that adds up to 180. You know you're correct. We have one last concept, and it's the concept of exterior angles. Exterior angles. You have three interior angles. Let's sweep the interior angles here. The interior angles are the angles inside a triangle, and they always add up to 180. Then you have what's called exterior angles. They're the three, I call them pinwheel angles. You will understand why they're called pinwheel angles in just a moment. We are going to extend each side and sweep clockwise. Clockwise is going around like so. What I'd like you to do is extend this side, extend it. And we're going to go clockwise, which means to the right and around. Extend this. Get that third side to the right and around. Extend this. These are called exterior angles. These three angles, when you extend one side of the triangle, the angle on the outside is called an exterior angle. Now this one says extend each side and sweep, which should be counterclockwise. So you can see it can go both ways. Counterclockwise, which is against the clock, so that's towards the left. So let's extend. Now sweep these. Those are called, again, exterior angles. Exterior angles. Both clockwise and counterclockwise. That you can see why I call them pinwheel angles. They resemble a pinwheel. Now these exterior angles have a very simple property, and that is this. Every single exterior angle is equal to the sum of the remote interior angles that is opposite of it. For example, this exterior angle 4 is going to equal to the remote, which means far away, but interior angles. This exterior angle is equal to the remote interior angles added together. So, for example, angle 6 is going to be equal to the remote interior angles of angle 3 and 2 added together. Angle 9. Angle 9 will also be equal to the angles that are inside the triangle but far away. That's why they're called remote. So guess what? In this case, 9 is also angles 3 and angle 2 added together. Angle 4, here, remote interior, remote far away, interior still inside the triangle. Angle 4 is going to be equal to angles 1 and 2 added together. Angle 7, remote interior angles, is going to be equal to the angle 1 and 2 again, added together. What I'd like you to do now is for these two simple problems, hit pause, attempt these two problems on your own, then restart the video. Okay, welcome back. Angle 5 is equal to angles 1 and 3 added together. And of course, angle 8 is equal to the same two angles added together, which is going to be 1 and 3. Down here, we want to find the measure of angle A, which we don't know. But we do know that this exterior angle C, that big exterior angle, equals to the remote interior angles added up together. Notice I'm making a thing equation before I do algebra. The exterior angle is equal to the remote interior angles added together. My exterior angle, circle, circle, plug it in. Circle, I don't know it, I'm going to call it X. Circle, 79. We're going to solve for X, obviously. Minus 79. And X is 36. Here's your check. Let's check. 36 plus 79. That's going to be 15. Carry the 1. 115. There's your check. It matches. Please review these pages carefully and to be prepared for our next class.